dear students, in this lecture we are going to see another inventory model, that is a quantity discounts for EOQ. What will happen when we buy at large quantities? The seller used to give some discounts on their price. So, when they give their price, we are tempted to buy more. When we buy more, there is a possibility our holding cost may increase. So, we need to have the trade off between our holding cost and our whether we have to avail that offer or not. So, that kind of inventory model we are going to see in this lecture. So, the agenda for this lecture is quantity discounts for the EOQ model. Quantity discounts occur in numerous situations for which suppliers provide an incentive for large order quantities by offering a lower purchase cost when the items are ordered in large quantities. So, whenever we buy the larger quantities, the suppliers they reduce the purchase cost, they give the price discounts, so that you will buy more, but we have to be very careful whether we can take that offer or not. So, in this lecture we show how the EOQ model can be used when the quantity discounts are available. Assume that we have a product for which the basic EOQ model is applicable. I will show you the table. Instead of a fixed unit cost, the supplier quote the following discount schedule. So, this table shows that if you buy, you see discount category 1, 2, 3, order size, discount percentage and unit cost dollar. Suppose if you buy quantity between 0 to 999, there will not be any discount. So, when you order size is more, it goes in between 1000 and 2499, there is a 3% discount on the unit cost. Okay, there will be 15%, so there will be 5 minus 0.15, it will be 4.85. If you buy above 2500 and above, you see they are giving 5% discount. So, the selling price is, the purchasing price is only $4.75. So, the 5% discount for the 2500 unit minimum order quantity looks tempting. So, we used to buy more because the selling price is less. However, realizing that higher order quantities result in higher inventory holding cost, should be very careful on this. When you buy more, but we have to maintain that inventory, so that the inventory holding cost will increase. We should prepare a thorough cost analysis before making a final ordering and inventory policy recommendations. That is what we are going to do. We are going to answer whether we should go for this discounts or not, whether offering this discount, whether taking this discount from the supplier, it is saving our cost or not. Suppose that the data and cost analysis show the annual holding cost rate is 20% and the ordering cost is $49 per order and the annual demand of 5000 units. So, the question we should answer is what order quantity should we select? If they give the price the quantity discounts, so what should be the order quantity? There are 3 steps procedure is there to solve this kind of problem. The step 1 is, for each discount category compute a Q star. Q star is using our traditional EOQ model. What is EOQ model? 2D C naught by CH square root, that is our Q star. So, for each discount category compute a Q star using EOQ formula based on the unit cost associated with discount category. Step 2, for the Q star that is too small to qualify the assumed discount price, adjust the order quantity upward to the nearest order quantity that will allow the product to be purchased at the assumed price. See, for example, say there are 3 intervals there. Okay. So, we have to find out say for example Q1 star, Q2 star, Q3 star. The first step we are finding Q1, Q2, Q3. Look at the step 2 for the Q star that is too small. For example, Q star is very small. If it is very small, we cannot avail this discount price. Okay. So, if that time what you have to do? We have to order the quantity upward to the nearest order quantity. So, we have to look at the right hand side, the upper limit for which quantity we can get the discount. So, that will allow the product to be purchased at the assumed price. The third step, for each order quantity resulting from step 1 and 2, compute the total annual cost using the unit price from the appropriate discount category. The order quantity yielding the minimum total annual cost is the optimal order quantity. One important point I wanted to say, so far we did not consider the actual purchasing cost, but here we are going to consider that demand and multiplied by the unit cost. So, here we are going to consider the actual purchasing cost apart from your ordering cost and holding cost, because this quantity will decide. So, the quantity, how much quantity you are going to buy, that will decide whether the cost is minimum or not. So, what is the step 1? For each discount category, compute a Q star using the EOQ formula based on the unit cost associated with the discount category. So, in the preliminary calculations, there are 3 categories given. So, Q1 to indicate order quantity for discount category 1, Q2 for discount category 2, Q3 for discount category 3. So, look at this table. So, for each one we are finding Q1, Q2, Q3. In fact, it is a Q1 star, Q2 star and Q3 star. So, we know the formula Q star is 2D C naught by CH. So, holding cost is percentage in interest rate multiplied by the unit cost. Here there is no difference on ordering cost, but the holding cost will change, because for different interval there are different cost, the value of C is different. So, for example, Q1, okay, demand is 5,000 units, ordering cost is $49, the inventory holding cost is 0.2 multiplied by 5, see this 5. For Q2, 2D C naught 0.2 multiplied by 4.85. For Q3, it is 4.75, Q3 equal to 2D C naught by CH. So, we got Q1, Q2 and Q3. Because the only difference in the EOQ formulas come from the slight difference in the holding cost, ordering cost is same. The economic order quantities resulting from this step will be approximately the same. However, the order quantities will usually not all be of the size necessary to qualify the discount price assumed. In the preceding case, both Q2 star and Q3 star insufficient order quantities to obtain their assumed discount cost of $4.85 and $4.75 respectively. Because what is the value of Q1? Value of Q1 is 700, yes, the 700 is within this interval. When you see the Q2 is 711, you see that if you order in the interval 2 711, so we need to have minimum 1000 units. So, the Q2 star is not qualifying. So, if it is not qualifying, which is the higher side? Higher side is 1000 units. So, we have to order 1000 units. For that, we have to find out what is the total price, total annual cost. Q3 also it is 718. So, 718 also not qualifying. So, we have to find out the ordering cost of having 2500 units. In step 2, for the Q star that is too small to qualify the assumed discount price, adjust the order quantity upward to the nearest order quantity that will allow the product to be purchased at the assumed price. For those order quantities for which the assumed price cannot be obtained, the following procedure must be used. For example, we got Q1 star 700, this is eligible, but you see Q2 star 701, 711 it is not eligible. Similarly, Q3 708 also not eligible. So, what we have to do, this adjustment causes us to set Q2 equal to 1000 units, Q2 star, Q3 star is 2500 units. So, what we are going to do in the step 3, if Q1 star is 700 units, if Q2 star is 1000 units, if Q3 star is 2500 units, we are going to find out the total cost. So, whichever is the minimum, that quantity needs to be ordered. If a calculated Q star for a given discount price is large enough to qualify for a bigger discount, that value of Q star cannot lead to the optimal solution. What is the meaning? For example, we got Q1 star is 700. Suppose you are getting the value of Q1 star is say 1200. Okay. So, that we cannot consider the option 1, because the Q1 star is exceeding the first interval, it is goes beyond 999. So, that category of offer is not optimal. So, we have to omit that the first option, then we have to do only for the second option. Step 2, for the Q star that is too small to qualify for the assumed discount price, adjust the order quantity upward to the nearest order quantity that will allow the product to be purchased at the assumed price. So, if a calculated Q star for a given discount price is large enough to qualify for a bigger discount, that value of Q star cannot lead to an optimal solution. In the previous inventory model considered, the annual purchase cost of the item was not included because it was constant, never affected by the inventory policy decision. So far the previous inventory models we did not consider annual purchasing cost. However, in the price discount model, in the quantity discount model, the annual purchase cost depends on the order quantity and associated unit cost. So, in this method you have to consider the annual purchasing cost also. So, the annual purchasing cost is annual demand multiplied by the unit cost is included in the equation for total cost. So, there are 3 elements there. What are they? Annual holding cost, annual ordering cost plus annual purchase cost, because the value of C differs. So, we need to consider this element also. So, using this total cost equation, we can determine the optimal order quantity for the EOQ discount model in step 3. So, in step 3, what we have to do for each order quantity resulting from step 1 and step 2, compute the total annual cost using the unit price from the appropriate discount category. So, what we need to do? Compute the total annual cost using this formula, that is annual holding cost, annual ordering cost plus annual purchasing cost. The order quantity yielding the minimum total annual cost is the optimal order quantity. So, step 3 calculations for the example problem are summarized in the below table. So, we will take one sample example, we will explain all the steps. The total annual cost calculations for the UOQ model with quantity discounts. So, we got the Q1 star is 700. For that, what is the annual holding cost? We know the formula for annual holding cost is Q by 2 average inventory multiplied by holding cost. Holding cost is 20% multiplied by $5, 350. Ordering cost is number of orders D by Q, D is 5000 minus 700 multiplied by ordering cost, so 350. Then the purchase cost, the demand is 5000 units. If you go for 700, the purchasing cost will be $5, so it will be $25,000. Total it is $25,700. The second interval, if you go for 700 units, the cost is 4.85. Then what will be the holding cost? Q by 2 multiplied by 0.2 into 4.85, so 485. What is the ordering cost? D by Q, 5000 divided by 1000 multiplied by ordering cost, 249. Then purchasing cost 5000 multiplied by 4.85, you see that previously 5, it is a 4.85, so 24,250. So, when you add it, it is 24,980. Suppose if you are buying 2500 units, the buying cost is 4.75. So, the average inventory 2500 divided by 2 multiplied by holding cost, it is 1188. Ordering cost, number of orders multiplied by, this is 49, so $98. So, when you add it, it is coming. So, purchasing price, what is the purchasing price? 5000 multiplied by 4.75, that will give you 23,750. So, the total cost is $25,036. So, out of these three, which is minimum? So, this one is minimum. So, our inventory policy is we should go for ordering 1000 units. As we can see, the decision to order 1000 units at the rate of 3% discount rates yield the minimum cost solution. Even though 2500 unit order quantity would result in 5% discount, its excessive holding cost makes it the second best solution. So, you see that the Q star equal to 1000 provides the minimum cost order quantity. Now, with the help of Excel, I am going to explain how to plot these values. Now, I am going to explain the total cost principles with the help of this Excel model. So, I have taken the value of Q and corresponding total cost. For example, say B2, see that B2 is 100 units, what will be the total cost? So, click on C2, see the total cost is average inventory multiplied by inventory holding cost plus D by Q multiplied by ordering cost plus purchasing cost. You see up to 700 we got the value of Q1. So, in our model Q1 star is 700. So, I have kept up to 700, I found the total cost. The Q2 was 1000 units. Okay. So, when I increase the ordering quantity, then correspondingly, for example, when you click on C15, for C15 you see the total cost, we got this much. So, the Q3 was, the Q3 star was 2500. So, then if you see the C23, the formula C23. So, as usual we have written the annual holding cost plus ordering cost plus annual purchasing cost. So, when I plot that, see the right hand side you can see the figure, the total annual cost is less if you order 1000 units, not exactly 1000 units, but you see when you go for 2500 units, our total cost is above 25,000. So, by looking at this figure, we are concluding that so ordering 1000 units is most optimal ordering quantity for us. Now, I will go back to the presentation. Now, look at this here. Here it is the most optimal quantity. You see that here also we are getting lesser quantity, but when we go for this is 1000 units, we are getting the least total cost. So, our conclusion here is we should go for ordering 1000 units. Now, I have taken another problem to explain this concept with the help of another example problem. What the problem says, a shoe store carries a basic black dress shoe for men that sells at an approximately constant rate of 5000 pairs of shoes every 3 months. The shoe store's current buying policy is to order 500 pairs each time an order is placed. So, what are the cost details? It cost shoe stores $30 to place an order. So, ordering cost is $30. The annual holding cost rate is 20%. With the order quantity of 500 units, shoe stores obtains the shoe at the lowest possible unit cost of $28 per pair. Now, there is an offer for them whether they should go for 500 units. Now, the seller is giving the offer. What that offer says that if they buy 0 to 99, it is a $36 buying price. If it is 100 to 199, it is $32. If it is 200 to 299, it is $30. If the company buys more than 300, it is $28. So, now the question is, what is the minimum cost order quantity for the shoes? What are the annual savings of your inventory policy over the policy currently being used by these shoe stores? What is the current policy? They are ordering 500 units. So, now the supplier is giving a discount policy. So, we are going to compare whether should I continue with my current policy or I have to take this offer, which is most profitable for me. So, what is the first step? We have seen previously, the first step is we have to find Q1, Q2, Q3 and Q4. Before that, first we will find out the total cost for existing inventory policy of ordering 500 units. Now, the total cost is, because they are ordering 500 units, so Q by 2 multiplied by the annual holding cost plus number of orders and ordering cost and the annual purchasing cost. So, if they go for this policy ordering 500 units, so the total inventory cost is 57,520. Now, there is an offer by the supplier. Now, we will see what will happen whether we have to go for this offer or not. So, the first step, what is the first step? We have to find out, here we have to find out Q1 star, Q2 star and Q3 star and Q4 star. Okay. So, here I found this Q1 star, Q2 star, Q3 stars and Q4 stars. Now, look at the Q1 star, it is 129, but you see that it is 0 to 99. So, it is going to the next level. So, this is not valid. So, Q to obtain this interval need not be considered, we need not find out total cost also. The Q2 is 137, yes, it is within this interval. If it is 137, we have to find out what is the total cost. So, what is the total cost? Here there will be the annual for 137 units annual holding cost plus annual ordering cost plus purchasing cost, that is your 64,876. Look at Q3, Q3 is 141. So, 141 is not falling in this range 200 to 299. So, if it is 141, what is the next highest upward side, what is the highest value? 200. So, for the 200 should be the order quantity. For this order quantity, we have to buy the total cost. Q3, The Q3 is 146. The 146 is not in this interval because we can avail this $28 price only if we buy more than 300. So, instead of order quantity is 146, we should consider 300 units. For this 300 units, you have to find out the annual holding cost plus ordering cost plus annual purchasing cost. So, that amounts to 57,040. Now, look at this Q2, Q3 and Q4, which is the lowest one? The lowest one is this 57,040. You remember previously, if you buy 500 units, there was some price, but if you go for 300 units and if you avail this discount of $28, you are getting the lesser annual total cost. So, our conclusion is we should go for the inventory offer. So, what happened? You look at the first category, Q star is greater than 99. So, this column need not be calculated. Now, what happened that if you go for this offer, okay, instead of 500, if you order 300 pairs per order, the annual saving is 480. How we got this annual saving is 480? So, previously what was the price? 57,520. So, 57,520 minus 57,040. So, the difference is $480. Okay. But note that this shoe will be still purchased at the lowest possible cost of $28. See this $28. So, our conclusion is this shoe company should go for taking this offer. If they take that offer, instead of ordering 500 units, if they order 300 units, they will save the inventory cost. How much? $480. So, dear students, in this lecture I have explained the quantity discount model. In the quantity discount model, what we have learned, there are 3 steps. What is this 3 steps? Step 1 is, for each interval we have to find out the optimal order quantity. For example, Q1 star, Q2 star, Q3 star, if there is a 3 interval. The step 2 is, if any optimal order quantity is not lying that interval, we should find out the next highest value. Okay. For that value should be our ordering quantity. The step 3 is, now we have to find out the total annual cost for all these 3 ordering quantities. Whichever is a minimum, that much quantity need to be ordered. And one more thing, when compared to the previous inventory models, here you have to consider the annual purchasing cost also, because that will influence your annual total cost. The next class we are going to talk about a very interesting model, that is newsboy model, that we will see you in the next class. Thank you very much.